Hi, my name is Todd Campbell. I'm at the University of Connecticut. I'm just going to share briefly with you about an article that my colleague Drew Nilsson, he's a physics teacher in Logan, Utah. We developed, and it'll be out this summer in the Science Teacher. The article is just I think it's the continued evolution of how we think about designing units of instruction in the physics classroom so that students can reason about kind of everyday phenomenon that happens in the world. So we've focused on using modeling as an anchoring practice for students to work at understanding something, but also for them to publicly represent how they think about the ideas that they're trying to use. So in this particular article, I'll just highlight some things that we've tried to share. One is just an example unit. We've used ramps they're structurally different ramps where we have students try to explain why a marble might travel down one faster than the other. We have kind of a real life story that we can attach to this, especially in Utah, where we talk about if a skier's out on the slopes and he's racing another skier, he or she, and they want to get to a particular place faster, and they have two different routes. What kinds of features of the routes might they look for in order to get them there faster? But in the particular article in the Science Teacher, the shorter version that's in print, there's a longer version that's online that has that example in it. We just focus on the structurally different ramps that they see in the classroom. Also in the article, so we highlight some of the design strategies that over time we've continued to refine. And these design strategies we've adopted or developed on our own, and we talk about how we organize them across a unit to engage our students. So you can get a sense of how we go about developing instructional units and how we share those units with our students. So some examples of important design strategies that we use. I'll just highlight two. One is like making sure we identify a complex anchoring phenomenon that would capture the student's interest, but that also would require them to use some central science ideas to explain this phenomena. Another one might be partition modeling templates. So particularly in the ramp and maybe in other phenomena, the thing that's really important that we want students to focus on is that thing that changes in the phenomenon over time. So making a partition template especially for the ramps, like the first section, second section, third section, maybe foregrounds the need for students to talk about the changes that happen over time. So these are just two examples of what we've tried to share in the article, and we hope you enjoy it, and we love feedback from you about our work, and we'll keep working to improve it. Thank you.